Hello aspirants and welcome again to Legacy IAS Academy. In this lecture, we will be discussing about the Nobel Prize in Physics which has been given for macroscopic mechanical quantum tunneling. So we'll understand what is this quantum physics, what is this macroscopic quantum tunneling that we are talking about, so on and so forth. So let's get started very firstly with the news and who are these people who have received the prize. So these are the three people in front of your screen: Mr. John Clarke, Michel Devoret, and John M. Martinis. So these are the people who have won the Nobel Prize for Physics for their work or for their discovery of the macroscopic quantum mechanical tunneling and energy quantization in an electric circuit. Now you have to remember this concept for which they have won it specifically for your prelims. We will now go into the detail of understanding what is this quantum physics first thing, and second, what is this macro and micro level of quantum physics. Now remember, there was a Nobel Prize in the year 2022 also in the field of quantum mechanics. So now again quantum mechanics has won it, which will basically create a renewed focus of the scientists and the countries in studying quantum mechanics. So let's get started with the news. Before that, a special announcement with respect to the new batches that are going to start at Legacy IAS Academy. So once you enroll, you will be taught, mentored and coached by the experts in the UPSC civil services examination domain. The batch size is kept very small, limited to only 40 in order to ensure personalized approach to each and every student. This batches will start from 16th and 25th of October, that is regular and weekend respectively. Now once you enroll with us, there are of course a lot of advantages. Some of them are listed in front of you. There will be comprehensive coverage of the GS paper, one-on-one mentorship, doubt solving and regular interactions with the mentors that you just saw. At the same time, there will be daily mains answer writing practice. Of course, there will be prelims as well as mains test series, and we have a 360-degree approach for current affairs, wherein the entire week's current affairs are covered through the live classes. So if you want to enroll with us, simply download the app or log on to our website or call on the numbers that are given below. So now let's continue with the news and understand the quantum mechanical effects. So there are certain quantum mechanical effects. So these are, number one is the tunneling. Now in tunneling, what happens is, it is said that the particles cross the barrier without classical energy. That is what quantum tunneling is. So let's understand with the help of this diagram. If you look at the classical mechanics, let's say this is that particle, this is the ball, and this is the barrier of a mountain in front of it. Now if you want this ball to cross this mountainous barrier, you will have to provide it with energy. For example, the kinetic energy. With the help of the force, if you push it with a force, what will happen is it is going to climb uphill and have a potential energy over here. The kinetic energy will get converted into potential energy. Kinetic energy is due to a force, due to the movement, due to the speed of the particle. Potential energy is due to the height of the particle at which it is situated, and then further it will come down, and this potential energy will again get converted into kinetic energy. Now this is how the classical physics works or classical mechanics works. Now in quantum mechanics, what happens is the particle need not necessarily go up and then down, can rather pass through or cross the barrier without providing the classical energy. And what are these classical energies? The kinetic and the potential energy. So without providing any kinetic energy, it can still transit from one place to another, or from before the barrier to after the barrier. That means within the barrier. At the same time, there is entanglement. Now quantum mechanical entanglement is again the concept on which the Nobel Prize was given in physics in 2022. Now this says that the distant particle influences each other. So all the distant particle will of course influence each other, is what is said. Now quantization in quantum mechanics, the quantization of energy concept says that the energy that is there it jumps in discrete levels, quanta, and not continuously. So for example, on a TV screen, for example, you will be seeing a light completely, right? So you feel it's a continuous picture that is going on, but that is actually not the case. The electrons on your screen will move from the left hand side, go completely to the right, and then come back, and then go again, and then come back, and then go again. It happens so fast that you feel that it is continuously present in front of you. So you feel it as a continuous thing, but it is a quanta or a discrete energy that is coming over here. I hope these concepts are clear for you. Now let's understand why this Nobel Prize is special. It is special because the quantum effects that we just saw is seen only in microscopic systems. So when you talk about microscopic systems, you are talking about the electrons, you are talking about the photons, right? You have your mobile phone or you have a metal plate. You see the metal plate as one thing, but inside that metal plate, let's say an iron metal plate, there are huge number of electrons which are moving rapidly with a huge amount of speed. So that is the microscopic level. Now this quantum physics is observable, these quantum effects are observable at microscopic level, but what these scientists have actually done is they have shown the phenomena at a macroscopic level. That means at a level which can be observed with the naked eye without the use of the microscope. Now out of the four quantum mechanics effects that we saw, tunneling, superposition, entanglement, and quantization, they have observed the phenomena of tunneling and energy quantization at a macroscopic level. Remember this, again important for your prelims. Now this is nothing but a development on a project which, or let's say an experiment which was already conducted in 1980s, in which the two superconductors were separated by a thin insulating. There were two superconductors, one here, and were separated by a thin insulating layer. Now what happens is, normally no current will escape the loop which is created, but what you observed was voltage appeared. Voltage means basically fluctuation in the current was observed. So when the current is fluctuating, it means what? That it is not continuous, but rather it is discrete and is being emitted in the form of a quanta. I hope that's clear. And then the circuit which was there was absorbing the energy in fixed quanta and not as a continuous process. This is all to the level that you have to remember for this particular experiment. Now another experiment was double slit experiment, which is not in news, but you can connect it to the quantum physics again. What was this double slit experiment? It is a simpler one. In a plate you have two slits, this is one and this is two. Now you pass the electrons, a beam of energy you pass which will consist of electrons. So you should see a continuous line over here, but you will not see continuous line. You will see lighter, darker lines alternatively, which shows that the light is not passed in a continuous manner but in a discrete quanta manner. So because of this, you can say that the electrons are being present as a particle and also as a wave. So they are present in two different forms at the same time, which is again a concept of quantum physics, which says that a particular thing can exist in two different states at the same time. Now, what are the applications of this quantum physics or quantum mechanics? Of course, to solve the complex problems, for modeling the molecules and other materials, to optimize the chemical reactions, to revolutionize encryption, encrypting, decrypting, encoding, which is required. India also has a national quantum mission having a budget of 6,000 crore for 8 years. It started in 2022, will go on till 2030. So also the quantum computing can solve more complex problems which the present computers are not able to solve. It is going to increase the power of the computers multi-folds, which is unimaginable. Of course, we have imagined that. That means it is to a very higher degree. So this is what the Nobel Prize is all about, and the basics of quantum physics which was taught becomes very important, especially for your prelims examinations. Thank you.